Alright, so the third video already. I must say, I am very tired. I had a very long week, and I hope I can still bring the enthusiasm I brought in the previous videos. I'm gonna try. If not, I'm sorry in advance. So, um, what are hash pointers, and how do they function within the Merkle tree? Well, hash pointers, very simply put, are just pointers that miners can use to track the history of transactions. So that's basically a hash pointer. Yeah. Now, if you look at that within the whole system of, let's say, Bitcoin, or the whole Bitcoin network, you can look at the global state of the network and look at that global state using the Merkle tree. And I think so. The Merkle tree is used to store data, partially store data, uh, in increasingly smaller branches. So each branches you would call a bucket, and within the bucket you have a piece of the information that you are trying to store. And um, if you trace each bucket, of course, has a hash code attached to it. And then if you are looking for some information, you could use, and you know the hash code, and you know the hash code for the start of the information, so for the top of the tree or from the bottom, it works either way. And then you start at, let's say, all the way at the roots. So you have the bucket with a part of the with a hash code attached to it, and that hash code is linked to a more upward part of the tree, and those are linked with the hash codes. In each bucket, each time you go higher and higher within the tree, you find the next piece of the information you are looking for, and then when you are all the way at the top of the tree, you have collected all the information you are looking for, and this is a way to store the data on the network, or store large amounts of data on a network without having the need to create entire databases. I think I am not quite sure about this yet because it was really difficult to understand it. Now, the hash pointers, those are used to um, those are used uh, uh, um, for those are used for by the miners to look up the transaction history, and in the same way, hash pointers could be used to look up pieces of information within a Merkle tree. I think if I am not wrong, I hope I'm not wrong, then this is what hash pointers do, and this is how hash pointers are used or within Merkle trees. Now, what I don't yet understand is how per se, or if per se, the entire Bitcoin network consists of one giant Merkle tree, or that if it is several Merkle trees, or even hundreds of Merkle trees, different ones for different types of information, and that even possibly those different Merkle trees are then again linked to each other with another No, that would be crazy. Linked with another Merkle tree. I don't know, but I read about it a lot, and it was hard to understand. It was hard to follow. It was, on the other hand, also really interesting. I think actually, now that I think more of it, that could be a possibility. I don't think it would make much sense to make one giant Merkle tree, because then the tree would just become so large you would get lost within the tree. So yeah, I think multiple trees linked through hash pointers, or maybe linked with the use of another Merkle tree, is actually a logical thing to do here. Yeah. Yeah, I think that is that is how merkle trees would work. I'm going to look that up, but I won't include it anymore in this video because that will cost me another 2 or 3 hours of research before I've looked it up, and then another hour of trying to make that into a video. So I'm gonna leave it at this. I hope I explained it enough to you, and yeah, goodbye. Have a nice day.